Hi, welcome again. So as you can see here, we have a borehole, and this is the point where we have a razor main. So today's task, we are going to see how we can size this submersible water pump, and again how we can size this razor main by using EPANET 2.2. Okay, so this is the mission that we have today. So if you are new here, this is the Hydroinformatics Academy, a place where we discuss a lot about technologies related to water supply and irrigation. So if you're interested, just subscribe, like this video, and that being said, I'll see you in the next part of the video. Now, before you start sizing your pump, or before you start designing anything related to water supply project with pumps, one thing that you need to have is pump test report. This is very important. You need to have pump test report, and from pump test report, there are some very important data that you need to extract from it. So for me, I have a PUMPSET. Of course, this I get it from pump test report. PUMPSET with 80 meter. Again, I have a borehole with this capacity. Design capacity, I just take 90%. So what I want here is to extract only 90% from my borehole. Okay, so 90% of this, which is this one, which again is equivalent to 1.4 liters per second. I have a ground level elevation at the borehole, which is this value here. I have a pump set elevation. So from the ground level, you go down 80 meters, which is pump set, or a place where our pump will be allocated, which is this elevation here. So you take ground level elevation minus pump set value, which is 80, you get this value. The next point here we need to have is this riser tank elevation. As you can see here, this is the value, and again total riser tank elevation, which again is this one. This is very important. This one is a riser tank elevation. Not just that, we have a tank capacity of 45 cubic meters with, of course, height of water is this one, and again this one here is a diameter. Okay, this is very important. So from here, the next data that we need to have is survey data. As you can see here, I have mine here. So this is eastings, northings, and elevation. Of course, we need to take this data from Excel to the format that is compatible with EPANET, but for the sake of this tutorial, we're not going to cover it. But I have a full tutorial that explains how to do such a process, and I'll make sure I include it in the description below. So you will find a link to that tutorial in the description below. That being said, I have my data, which is processed already. As you can see here, this is a DXF file, and this is .inp file. Of course, this is a file format that works with EPANET. I repeat, if you want to know how to do that, a link to that tutorial will be in the description below. So we are going to take it from here. I open my EPANET. So the first thing that we need to do is to open EPANET. So for me, I use EPANET 2.2, as you can see here. Now, what we need to do is, of course, to go to File. Then we need to import. We need to import this file here. We need to import this file, WSBH. We need to import it. So from File, then Import, then Network. Okay, so this is my file location. As you can see here, we have this .inp file. Now, just click Open. So this is my network. As you can see here, this is a pump location. This is my borehole. Oh, this is a point where our submersible pump will be installed. And again, this is the point where our riser tank is located. Okay, so I will need to get rid of this because we are not going to deal with this. Just get rid of this. Now from here, let me delete this. Few minutes. Let me delete this. I need to select this. Oh, now select this. So this, I need to delete all of this. So this is my tank location. Again, we need to delete some points here. Okay, so this is my razor tank location. Now here you cannot just go here and just place your tank. That's not gonna work. So what we need to do is take this out. I'll take this out and I will introduce here my razor tank. Again, from here to here, I mean the pipe that I removed was had a length of what was it, 32.55 diameter, and roughness we will change later. And again, our tank. Now tank elevation, as I said earlier, this is our tank elevation here. But one thing that we need to keep it in mind, this value here, okay, let me do this. Our tank elevation here is 1195.1. Remember, initial level here we'll put here as 3. So if you take 1195 plus 3 is actually this value here, okay, 1198. So from here minimum level is 0.3, and again maximum level is again maintain 3. Okay, so if you take this value, you plus 3, you are going to get this one. So that is very important. And diameter here was 4.5. Another thing here, of course, we have nothing left. Initial level is this. So we are done in this part. Now let's go back here to our pump. As you can see here, this node elevation is 119597. So this is ground level elevation. As you can see here, ground level elevation is this. So we need to add elevation, pump set elevation, which is this one. Okay, so what we need to do here, you cannot delete this. What we need to do is to add another node, let's say here. Then from here we need to introduce here a pipe. Now from here, so a pump set elevation is, as I've said earlier, 1117.2. okay, base demand here is 0. Now from here we need to add an aquifer. Now we don't have aquifer per se in EPANET, but we have this reservoir. So this reservoir is going to act as an aquifer. So from here we need to draw our pump. So from our reservoir to this node here, this is our pump. Remember, take your pump from this to this. Your direction should be pointing this direction here, where our water will be flowing. So from here, what next? Now if you have your pump, the next thing that you need to do is to introduce pump curve. But before we go to pump curves, let's set here, let's modify our settings, our project settings. Now let's go here to project, then defaults. Make sure that you are, of course it's depending on the unit that you prefer to use. So for me, I want to work with metrics. So with metrics, our flow here we can set liters. I'm going to use liters per second, and head loss formula I'm going to use Hazen-Williams. Of course you can use that's Spark as well. So nothing here we can change. This is very important, liters per second in Hazen-Williams. In properties, nothing we can change here. Label, of course, for this project we are going to change nothing. So if you change anything, you can even set as default. So for me, nothing I change, so cancel. Again, you can go here and change preferences. So for preference, I don't think if there is anything that you can change. So if you want to change anything, just do it the way you prefer. So for me, nothing I can change. Now from here, we have our reservoir here, okay, which is aquifer. Now this is our pump, and this is our pump set with this elevation here. This is our ground level with this elevation. Now what we need to do here, we need to introduce a pump curve, okay, a pump curve. So let's go here to our browser and click curves. I think it is this one, curve. Now from here we need to click this this icon here. So a pop-up window like this will come So a few things that we need to keep it here in mind. The first thing is curve ID, this one. Of course, you can give it a name that you prefer. So for me, I'll just leave it as 1. Okay, this is very important. Again, curve type, we are going to work with pump curve. So here is the value that we need to fill. So in flow, we need to put here a design flow, and head, of course, we need to put a design head. We'll put here a design discharge as 1.4. Actually is 1.4125. That is a design flow. So head here will just maintain 90, at least 90. Let's put here 90, and I will tell you next what we are going to do with it. Just let's put here 90, and let's see what we are going to have. Now the next thing here we need to do is actually to change our pipes. As you can see here, we have pipes with internal diameter of 12, which is very small. Okay, so let's change here. So from here, just, of course, you can change one pipe after another. I think that will be a very tough job. Of course, let's go here to this point here, edit, then click select all. After that, click group edit. Now from group edit, we need to select all pipes. We want to replace the diameter. Okay, let's start with at least 2-inch pipe. 2-inch pipe. So 2-inch pipe with internal diameter of 69.2. Remember, this is the HDP. So click head, click OK, then OK. Again, let's go back here and change the roughness. Remember, we are dealing with HDP pipes or plastic pipes with roughness 140, not 100, 140. So then click OK. Okay, so now we are done. Let's run our model and see what we have. Let's see what we have here. So it tells us that no head curve or power rating. Okay, so let's go back here to our pump. I think we forgot to put here our pump curve. Remember pump curve ID. So for me it was 1. I'll keep here 1, and let's run, and let's see what we have. Pump 3 is closed, cannot deliver head. Okay, elevation here is 1.1 is this one. So as you can see here, our reservoir here, which represent our aquifer, we put here 0. So we need to put the same elevation as this. So you can see here is this value. So we need to take this value and put it here. Okay, yeah, as a total head. So 117 point. Okay, let's run again and see what we have. So at least now everything is fine. At least for now, everything is fine. But one thing here we need to keep it in mind. Now before we proceed, let's do this. Just right click anywhere in this dash, in this area. Just right click and click option. What we need to display here is go to notation and display node value and link value. And again, we will just click OK. From here, run again. Now let's go to browser, map, then select pressure. So on every node we need to display pressure. Just click pressure here. As you can see here, you have all your pressure. So the next step is to display flow on each link or on each pipe. But before we go to that point, I'd like to cross-check something here. So this was our ground level with this elevation, the same as this one here. And again, this point here is our pump set, which with this elevation, of course, at the depth of 80 meter, which is this. Now from here, from our pump here up to the ground level, we have a pipe with internal diameter of 40.8 millimeter, which is again this one. Okay, 40.8 millimeter, and length from this point here to this point is 80 meter, just like this one. Okay, now from this point, let's display flow on each link. Now from each link here, just click drop down and display flow. As you can see here, we have 1.26 and not 1.412 liters per second. Now what we need to do, let's go back here to our curves and select here. Now as you can see here, yes, we assigned the value of 1.4, but our pump is actually delivering 1.26. This is not what we desire. What we want is 1.4 and not 1.6. As you can see here again at this point, let me see, at this point here at our tank, so the amount that is coming to the tank here is 1.26. So we need here 1.41 liters per second. Now what we can do here, let's try to play with our pump, with our head here. Now from 90, let's take it to 95 and see what we have. Now let's run again and let's observe our flow. Okay, now flow here is 1.35. That's very important, 1.35. As you can see, up to now we don't have any negative pressure, which our model tells us that water is flowing. But yes, water is flowing, but the discharge is not the discharge that we want. So we need to make sure that we achieve 1.4 liters per second, which is the discharge that we want. Okay, so from here, let's take it again to 100 and see what we have. At least now we have 1.42 again at our tank. So the discharge that is coming to our razor tank here is 1.42, which is not bad, because what we wanted is 1.4125 liters per second. So if you have 1.42 liters per second, is actually not bad. So pressure here is 80.9 meters. Of course, this is residual pressure. And again, if we go back here, so this is our system. This is our system. But what we need to keep it in mind is that up to now we designed our system with a pump with total head of 100 meters and flow this. Now let's ask ourselves again, is there anything else that we can do in this system? Now before we move to that part, let me check again here. So this is flow. Let's check velocity. As you can see here, you have velocity of 0.38, which is not bad, because at least we need to have at least 0.4 meters per second. I mean, it's depends from country to country. 0.4 up to 0.5 can be a minimum velocity. So for me, this is not bad. And again, if you check to unit head losses, again, losses are quite small, because it is advised to have at least 5 meters after every kilometers. 5 to 10 meters of head losses per 1 kilometer. So for me, this one is not bad. So this is a case number 1. Okay, case number 1. Remember, we have here a pump of 100. Okay, total head of 100 meters, and discharge again is the same. Now what we need to do here, let's try to play with this around. Let's try to change at least to reduce the pipes from 2.5 inches pipes to at least 2 inches and see what we have. Okay, let's reduce it to at least 2 inches and see what we have. Now what we can do here is to introduce another curve here. Of course, our design flow will remain 1.4125, and again head, let's start with 100 and see what we have. Now in our pump here, now at our pump curve here, let's set it to 2. Now what we need to use now is this curve here, not this one, not this with 100, but this number 2. Okay, number 2, just with ID number 2. And what we can do here, what we can do is actually changing all our pipes select all, and again go back here and group edit. Now from here select pipes and diameter. Now we need to change it from 2.5 to 2 inches pipe with internal diameter of 58. Okay, let's change all pipes, but remember this pipe here we need to take it back, of course this one, which is actually this coming out of our pump. Let's change it back to 40.8. Normally this pipe will be small, that's normal. Now let's run. Okay, now from pump here, pump curve 2. Now as you can see here, let me go back to pump curve. As you can see here we have this. Okay, so let me increase head to 1110. Our flow, of course we don't have any negative value, which our model tells us that water will flow. Now here we have 1.19 liters per second. That's not what we want. When we run again, 1.3. Let's change again to 120. No, 120. Okay, so this is something that we achieved for case number 2. After changing our head to 120, this is what we get. So our discharge now is 1.41, which is exactly what we want. And if you come back here again and look at this, so our pump now is delivering 1.41 as a discharge to our razor main tank. Now this is case number 2. Okay, this is case number 2, whereby we have a pump with a total head of 120, and again our razor main is designed with 2 inches pipe. Okay, 2 inches pipes. That is very important. Now this is a point you as an engineer or you as a water expert, you need to take it into account. When we design, we are not just looking at pressure, velocity. It's not just that. You need also to keep in mind the economic part of your project. As you can see here, we have 2 cases and they are both working perfect. Okay, both of them, they are perfect. Now what we need to do here is you now go and compare which one is cheap or which one is not that costful. So for me, I will go with this one. Again, if you go here and look, so for case number 2, if you go here and look velocity, you have 0.52, while for the first case we had 0.38. Okay, that's very important. So for me, I'll just take this one. Even though here, if you look at the unit head losses, we have 6. Of course, it's again not that bad. So I'll take this one as my design. Okay, so I'll use this pump and razor main pipes. I'll use 2 inches. So that being said, this is the final part, but not over yet. We need also to see how can we extract our reports. So there are 2 ways that you can extract reports from your project. So the first step is to go here, this table here, and click. Let's start with nodes. Now from nodes, we don't want to see quality, but we want to see elevation. Then click OK. So this is the data. So at every node you have your pressure values here. Okay, so you can just click them and see. So this is a pump, if I'm not mistaken. As you can see here is 120. Okay, and way number 2, or the other option, you can just go here to project, no, not project, report, and select full. Now from full here, just select here this one, just give it a name that you prefer. So for me, I'll just keep it like that way, then I'll click save. Now what I need to do is to go back to my folder, which is this one if I'm not mistaken, then select open. So this is a full report. It have everything, so from pressure, from unit head losses, everything is in here. As you can see here, let me go back, let me go down here. You can see here, this is the pressure, this is head of course, and this is our demand, of course it is 0. This is the pressure, this is quality, water quality, and let me go back here again. This is our pressure, of course. This is the reservoir, and we extracted one. This is the reason that we have a negative, because we extracted 1.41 from a reservoir, which for our case is an aquifer. And not only that, we deliver 1.41 to our storage tank. That is very important. Okay, so this is a unit head losses, and this is a velocity. So this is a complete report. Okay, so you can just take it from here and print, maybe share with your client, okay, or just keep it as for your records. So that is it. That is it. Now the next step, as I've said, I have a full tutorial which explains how to extract coordinates from Google Earth. Not just that, I have another tutorial which explains how to prepare your data so as they are compatible with EPANET. As I said, I'll make sure that I include both of them in the description below. That being said, please don't forget to share this video, to like if you get something out of it, and most importantly, subscribe, and I will see you in the next part, in the next video. Thank you.